Okay, our next lesson is going to be on the Pythagorean Theorem. Make sure you have your note packet or your note sheet out to write down the theorems that we have for today, and have some additional note paper to write down any of the examples. Well, let's get started. First of all, the Pythagorean Theorem you should be pretty familiar with. If you look here, we have the c squared equals a squared plus b squared. You've done that many times. Just remember that we have to have a right triangle in order to use the Pythagorean theorem, and the only requirement is that C has to be the hypotenuse. Otherwise, it doesn't matter where A and B go. Okay, Pythagorean triple may be a new vocabulary word for you. A Pythagorean triple is just a list of 3 side lengths that fit in the Pythagorean theorem. So they meet the a squared plus b squared equals c squared, but all of the numbers are integers. So one very common example of that is our 3, 4, 5 triangle. That's a set of a Pythagorean triple that a lot of times is used in construction. And if you check that, we have 3 squared plus 4 squared equals 5 squared, because 9 plus 16 equals 25. So 3, 4, 5 is a Pythagorean triple. Plus, any multiple of 3, 4, 5 is also a Pythagorean triple. So I could use 6, 8, 10, taking all of the sides by 2. I could do all of the sides by 5 and get 15, 20, and 25. And I could keep going on forever and ever. As long as I multiply this 3, 4, 5 times it, I get different Pythagorean triples. First example, find the length of the hypotenuse and tell whether or not it is a Pythagorean triple. So in order to be a triple, it just means that we would have to get a number here that's not a decimal. So I'm going to set this up. We're going to let the hypotenuse be c. So I have 7 squared plus 24 squared equals c squared. And if I use your calculator if you need to, go ahead and multiply those. So 7 squared is 49, 24 squared is 576. Add that together, I get 625. So c squared is 625. Take the square root, check to see if it's a perfect square. So just use your calculator, and it is. It turns out that that is 25. So there's your C value. And the answer to, is it a triple? That would be yes. The triple would be 7, 24, 25. Example 2. This time, we are looking for one of the legs of the triangle, so we'll let that be A. And remember, when we square C, we have to square the whole thing. So we talked about that a couple days ago. So x squared plus 144 equals, and remember this squared has to go to each part of what's in parentheses. So I have 6 squared, and I have square root of 5 squared. So you don't have to always write this whole step out. I just want you to make sure you understand that that would be 36 times 5, which is 180. So x squared plus 144 equals 180. We'll go up here. X squared is equal to 36. We just subtract the 144 from both sides. So take the square root. X is equal to 6. This is not a Pythagorean triple because we do not have an integer right here. So it forms a right triangle, it just does not give us what we call a Pythagorean triple. Example 3, we are looking for the hypotenuse again. This time we have a fraction. 3/2 squared plus 2 squared equals x squared. Remember, when I square a fraction, I just square the numerator and the denominator. And I'm going to go ahead and just get a common denominator, all without a calculator. So I'm going to make this 9/4, and I want this to be over 4. So I would have to multiply and get 16. 16/4 is the same as 4, but now I have a common denominator. Add the numerators, leave the denominator. Take the square root of both sides. These are both perfect squares, so the square root of 25 over the square root of 4 would be 5/2. Again, not an integer, so not a Pythagorean triple, but we do have a right triangle. Example 4. Pretty straightforward. We're missing a leg, so we have 81 plus x squared equals 441. Go ahead and subtract, and I get 360. And I need to take the square root of both sides. That is not an even square root. I get a decimal. So let's just go ahead and simplify it, leaving it in exact form. So the largest perfect square that I see is 36. And that gives you 6 square root of 10. Last example, this one wants me to go a step further, and that's find the area. So I know that my area formula is 1/2 base times height. But if I look at this triangle, I notice I'm missing the height. So I would draw that in, not very well, but I would draw it in, and that would have to be a right angle. And so that means I have to find the height of this triangle. Well, I've split it into 2 right triangles. Let's see if we can draw that a little bit better so that you can see. And not really much better. It's harder than it looks to draw on this. So I have a right triangle. This, since it's an altitude and it's isosceles, I know that I am splitting that base in half. So I know this is 5 and I know this is 5. So I would have 5 squared plus h squared equals 8 squared. So I go ahead and solve for h. So h squared is equal to 39. H equals the square root of 39. Now that finds h, but that's not what I was asked for. So I need to go over here and find area. The base now is the base of the whole triangle. So that's 10. And the height that I found was square root of 39. 1/2 times 10 is just 5. Square root of 39 cannot be simplified, so I'm going to leave it. I'm going to put my units squared on there. And that's my final answer. And that is it for today. Make sure you rewatch any part that you found confusing.